Hey guys, welcome to my channel. My name is Lokesh. I work as a lead architect. So in this video, we'll go over uh, the remaining section of chapter 10 of AI engineering book. So we have been covering the last chapter of this book, and I think whatever we have covered so far was around the architecture, how we can design the architecture for an AI engineering application. So once we have done that, it is very important for us to maybe have a or build a layer where we can start doing logging as maybe we can start monitoring how the application is working, because in any of the applications, be it a front end application or a back end application, it's very important to know how the application is going about in doing its uh, purpose that it was intended to build. And moreover, on top of it, whether the resources that the application is you know utilizing is adding to the cost or not. If it is exceeding whatever budget that was set out, maybe by monitoring it we can bring it down. And there could be some other aspects like whether the application that you have built is adhering to whatever laws and protocols for which the application was built for a particular country. If it is a global application, then in different companies you might have different rules and regulations. So you have to see whether your application is performing or operating within the boundaries. So with that, let's look into, or let's continue our journey. So we are in the section called monitoring and observability. So I think we had started exploring about monitoring and observability. At first hand, I think it looks like these both are similar terms, but there could be subtle deviations that we might need to look into. So maybe just let's go through and read this first two or three paragraphs quickly. So let's start. So even though I put observability in its own section, observability should be integral to the design of a product rather than an afterthought. The more complex a product, the more crucial observability is. Observability is a universal practice across all software engineering disciplines. It's a big industry that with established best practices and many ready-to-use proprietary and open source solutions. To avoid reinventing the wheel and focus on what's unique to applications built on top of foundation models, the books. Okay. The goal of monitoring is the same as goal of evaluation to mitigate risks and discover opportunity risks. That monitoring should help you mitigate include application failures, security attacks, and drifts. Monitoring can help discover opportunities for application improvement and cost savings. Monitoring can also help keep you accountable by giving visibility in your system's performance. Three metrics that can help evaluate the quality of your system's observability derived from DevOps community. I think it could be interchanging terms because, as you can see here, the author says writes rather in this section that since the mid 2010s, the industry has embraced the term observability instead of monitoring. So these could be changed, interchangeably. But I think maybe what we need to gain from this is that how we can, look at ways to improve our applications, and as I said in the beginning, how we can look to maybe see various parameters with which the applications can operate effectively, and we can get maximum rate of interest out. Yeah, I think that would be the right sentence, getting the maximum rate of interest out of the out of your application build by making sure that all the other parameters are taken care of or being taken care of. Three metrics can be evaluated, can help evaluate the quality of your system's observability. First is Mean time to detection when something bad happens, how long does it take to detect it? Mean time to response, self-explanatory. Change failure rate, the percentage of changes or deployments that results in the failures, the resulting fixes or rollbacks. If you don't know yourself, it's time to redesign your platform to make it more observable. This is an interesting parameter or benchmark, the percentage of changes or deployments that result in failure requiring fixes or rollbacks. So what it means is that, for example, you have tried to put in an enhancement. Let's say you design an application which was only meant for text generation, but now you have modified it and enhanced it so that it can also recognize the audio. So that would be an enhancement. But once you put that in production, once that goes live, and if the user starts complaining about it, that's where and how quickly you respond to that. No, I don't think it's about how quickly, it's the percentage of changes. Okay, so if the user has reported that enhancement, in the same example, if we talk about adding audio, then this means that this particular enhancement was not a success, it was a failure. So, and the higher the number of these instances are, the higher the change failure percentage would be, and that is something we'll have to be aware of, because if that happens, in my opinion, you might want to take your time before you push anything in production. And especially with big companies, they are able to do that quickly because they have a lot of dedicated teams, they have a lot of testing teams, and not only testing teams within the organization, they rely on some of the users which are called as beta users, so which would help you which will help you getting the data that the application is performing better. And if those beta users you know complain or raise issues, it means that you can roll back that particular enhancement or feature without taking it to the wider public. Having a high CFR doesn't necessarily indicate a bad monitoring system. However, you should rethink precisely, which is what I was discussing. Evaluation metrics should translate well to monitoring metrics. This is precisely what I was discussing. Monitoring versus observability. Since the mid 2010s, the industry has embraced the term set of monitoring. Okay, so now most of the organizations they use observability more than monitoring. Monitoring makes no assumption about the relation between the internal state of the system and outputs. You monitor the external outputs of the system to figure out when something goes wrong inside the system. There is no guarantee that the external outputs will help you figure out what goes wrong. Okay, let me just read this again. Monitoring makes no assumption about the relationship between internal state of the system and its output. You monitor the external outputs of the system to figure out when something goes wrong inside the system. There is no guarantee that the external outputs will will help you figure out what goes wrong. Okay, so monitoring mostly refers to looking at the output state of an application. Observability, on the other hand, makes an assumption stronger than traditional monitoring that a system's internal states can be inferred from knowledge of its external outputs. When something goes wrong with an observable system, we should be able to figure out what went wrong by looking at systems logs and metrics without having to ship new code to the system. Observability is about instrumenting your system in a way that ensures that sufficient information about a system's runtime is collected and analyzed so that when something goes wrong, it can help you figure out what goes wrong. So I think this is the difference that we were looking for. So monitoring, where in the monitoring, when we use practice called monitoring, We mostly would be looking at the outputs generated by the application, uh, and there is no relationship between those outputs and the internal workings of the application. Whereas in this observability, you have strong relationship between you, or you assume strong relationship between traditional, sorry, uh, you assume stronger relationship between the internal and the output, you know, internal inputs and outputs rather, sorry, and that is why it will help you change your application, or maybe help you more prudent with your code shipment to production, because you would know that if I'm deploying this, and this output will be affected, or vice versa. In this book, I'll use the term monitoring to refer to the act of tracking a system, to refer to the whole process of instrumenting tracking. Okay, so this particular line explains all. I think monitoring is just a part of observability, which is like the process of instrumenting, tracking, and debugging the system. Very well. Let's read on. Metrics. When discussing monitoring, most people think of metrics. However, metrics themselves aren't the goal. Frankly, most companies don't care what your application's output relevance score is unless it serves the purpose. The purpose of a metric is to tell you when something is wrong and to identify opportunities for improvement. Before listing what metrics to track, it's important to understand what failure modes you want to catch and design your metrics around these failures. I think I don't agree with this particular line. Metrics themselves aren't the goal, but I think a group of metrics might be a goal, and I assume the author is when the author says metrics, I think she might be referring to a data point. So let's say, again, considering the same example of adding audio to our Gen AI application. Now, if I'm trying to search for an audio, let's say I'm trying to search for a song, and I have maybe fired 10 queries, and out of those 10 queries, maybe it has returned the right song 5 times. So this, the success rate is also a metric. So maybe and maybe when you design the application, your goal would be to, bring down this or increase the success rate to 80%. So I don't completely agree with this particular line, but that's okay. Let's move forward. Before listing what metrics to track, it's important to understand what failure modes you want. Okay, this if you don't want your application to hallucinate, design metrics that help you detect hallucinations. One relevant metric might be whether an application's output can be inferred from the context. If you don't want your application to burn through your API credit, track metrics instead of related to API costs. Yeah, that I think I agree. So this solely depends on what sort of application you have built. So you should, have your metrics around it. Because foundation models can generate open-ended outputs, there are many ways that can go on metrics. Design requires analytical thinking. Okay, this book has covered many different type of model quality metrics and many different ways to compute them. So as I said, guys, this is just the one chapter of the book. I'm not going to read the entire book, but whatever the author is, talking about in this chapter or has written on that in this chapter, you would have a detailed subchapter around it. So, for example, if you're talking about monitoring and observability, there are certain chapters like chapter 4 to 6 or 3 to 5, which will go into the details of those. The easiest types of failures to track are format failures because they're easy to notice. For example, if expectation outputs track often how the model outputs invalid JSON, and among these invalid JSON, how many can be easily fixed. For open-ended generations, consider monitoring factual consistency and relevant generation quality metrics such as conciseness, creativity, or positive. Many of these metrics can be computed using AI judges. Yeah. So AI judge is also, one of the important parts of building a Gen AI application. So far, I think we, in this particular chapter, I think author has not touched upon this, but AI judge is vital cog as far as your Gen AI application is concerned. So let me just Gemini this. What is an AI judge? And let's try to look up what is an AI judge. An AI judge is a hypothetical or theoretical concept being referred to the use of artificial in judicial decision making. The future of AI in law is still unfolding. It's crucial to open AI systems. AI could assist human judges by analyzing vast amounts of legal data. Now, I think we are not talking about judicial decision making here. We are not talking in terms of the judge in the judge sense. Maybe let me just tweak this answer. Maybe the answer that has been generated here, maybe I think it's thinking that I'm asking about the AI judge, as in, a judge in real world. You have lawyers and you have law. So maybe in that context, he's thinking this particular tool is thinking that I'm asking it. So maybe let me just tweak this. What is an AI judge and Gen AI applications? An AI judge is a system that uses AI to evaluate the output of it. It's like having an AI that can create or access the work of another AI. Okay, this explains things: quality control, consistency, scalability, check the factual accuracy of information, assess the quality, evaluate the creativity and originality. Okay, got it. So it's another AI which can monitor the output of AI. If safety is an issue, you can track toxicity related metrics and detect private and sensitive information. Both inputs and outputs track how often your guardrails get triggered and how your system refuses to answer, detect abnormal queries to your system. Model quality can also be inferred through your natural language feedback and conversational signals. For example, some easy metrics you can track include the following: how often do users stop a generation halfway? What's the average number of turns per conversation? What's the average number of tokens per input? What's the average number of tokens per output? What's the model's output token distribution? So these are some of the metrics the author suggests that you may want to, calculate, especially when you're designing your metrics module or monitoring module rather, or observability module. Length related metrics are also important for tracking latency and cost, as long context and responses typically increase latency and incur higher costs. Each component in an application pipeline has its own metric. For example, in a RAG application, the retrieval quality is often evaluated using context relevance and context precision. A vector database can evaluate how much storage needs to index the data, and how long it takes to query the data. Okay, for RAG applications, the metrics around vector database make sense. But let me just go through this line again. Each component in an application has its own metric. For example, in a RAG application, retrieval quality is often evaluated using context relevance and context precision. Okay, the retrieval quality. So which means whatever the answer that is being, thrown by the RAG application, whether it matches with the context that was intended at the first case. If not, then the answer that has been returned would be deemed insufficient. Given that you will likely have multiple metrics, it's useful to measure how these metrics correlate to each other, and especially to your business North Star metrics, which can be daily active user, session duration, or subscription metrics that are strongly correlated to your North Star might give you ideas on how to improve your North Star. Metrics that are not at all correlated might also give you ideas on what not to optimize for. This is an important terminology, North Star metrics, which can be North Star metrics. I think I am reading the this particular terminology for the first time. Maybe this might be similar to USP for the products. But what North Star metric is, and there are certain metrics which will be very vital for the application or for the company, like daily active users, especially for the social websites, session duration, or subscription. So these are like North Star metrics or very important metrics that have to be gathered. Tracking latency is essential for understanding the user experience common. So now we are talking about latencies. And just to finish what we were discussing about this particular paragraph, whatever metrics that you need for arriving at your so-called North Star metrics, maybe you can just concentrate on that, and there could be some other metrics which you do not have to pay attention to at all. So those you can maybe park for now, park, and you can take it up later on. Tracking latency is essential for understanding the common latency metrics. Time to first token. It's time the time it takes for the first token to be generated, time per output token, the time it takes to generate each output token, total latency, the total time required to complete a response. Track all these metrics per user to see how your system scales with more users. The time it takes for the first token to be generated, TTFT. The time it takes to generate each output token. I'm thinking when they says first token, is it referring to only the token that is maybe a chunk of the input query that is being written, or the chunk of the output query that is being generated? So maybe let me just, so for example, if I'm talking about give me details about America's president. So in this case, maybe by token, when it says the time to generate first token, is it talking about converting just the word president into its corresponding token, or is it talking about the entire query as a single token? I think it's the first way around. But let me just type in here time and time generate first time taken to generate first token, right? TTFT, time taken to generate first token. What does token refer to it here? Is it individual chunk of the query or the entire query? In the context of, so this is in fact the chunk of the query, individual chunk of the query, and not the entire query. So as you can see from the answer returned from Gemini, and why it is important, because the time it takes for the application to generate your first token would actually define the time it takes for the entire query to be processed. And once again, Gemini has tried to come up with a real world example. Imagine you ask a chef to make a dish. The first token is like the chef understanding your order. The time taken to generate the first token is how long it takes the chef to understand your order and start generating the ingredients. If the chef takes a long time to understand your order, the entire cooking process will be delayed. Similarly, in Gen AI, a faster time taken to generate the first token means the AI can start processing your query and generating a response more quickly. So let's return to our book. You'll also want to track cost. Cost-related metrics are the number of queries and the volume of input and output tokens, such as tokens per second. If you use an API with rate limits, tracking the number of requests per second is important to ensure that you stay within your allocated limit and avoid potential service interruptions. When calculating metrics, you can choose between spot checks and exhaustive checks. Spot checks involves sampling a subset of data to quickly identify issues, while exhaustive evaluate comprehensive performance view. When computing metrics, ensure they have broken down relevant access such as users, releases, prompt chain, versions, prompt chain types, and type. This graphically helps in understanding performance variations and identifying specific issues. You will also want to track cost. I think cost is one of the most important metric, and it's very important to understand how the cost is distributed when you try to use a Gen AI model. So it's the author writes here, cost-related metrics are a general number of queries and the volume of input and output tokens, such as tokens per second. Number of queries and the volume of input and output tokens. If you use an API with rate limits, tracking the number of requests per second is important to ensure that you stay within your located limits and avoid potential service interruptions. So if you're using foundational models such as uh, Open ChatGPT, or for that matter, Gemini, Meta, these are foundational models. So you might want, so if you want to use foundational models, you have to make an API call to that. But there could be a limit imposed by the foundation models that you cannot exceed X number of API calls per minute. But if you do that, some of the APIs would have to wait, and that is where I think the latency will increase. So that is also important. And tokens also is important. Cool, then I think we got a good idea of what monitoring and observability is, and we'll continue with logs and traces in the next video. So I hope this video helped you guys, and if you gained something out of it, consider subscribing to the channel. We'll continue bringing more material to you guys, and in the process, uh, we'll continue our learning. Let's learn together, and because AI is designed for all. Thank you for watching my channel. Have a good day.